Hi everybody, today we're going to look at finding real zeros of polynomial functions and writing polynomial functions in factor form. Let's do a quick recap of what we've learned so far. We've talked about zeros of polynomials, and we found out when f of r is equal to 0 for any real number r, then x minus r is a factor of f of x, r is an x-intercept of f of x, and r is a solution to f of x equals 0. We also found out that when we have a polynomial function with integer coefficients, then any rational zero or root of the polynomial is going to have the form p over q. P is going to be a factor of a naught, the constant term, and q is going to be a factor of a sub n, the leading coefficient. So let's use all of that, put it together, and let's find the zeros of f of x is x cubed plus 2x squared minus 5x plus 2. So we're going to start with the rational root, which says look at p. So p is equal to 2, and it has factors of plus or minus 1 and plus or minus 2. Q is our leading coefficient, which happens to be 1 this time, and it only has factors of plus or minus 1. When we put those together and form these ratios p over q, we just get plus or minus 1 plus or minus 2. So this is nice as our first example. We have 4 numbers to put in. I'm going to show you how to do that using technology. I'll go back and forth between Desmos and the TI-84, so you have exposure to both. But if you're not allowed to use technology, or if you just don't want to, you always have the choice of plugging in the values. So you can find f of 1, f of negative 1, f of 2, f of negative 2. So you always have that choice, and that just means you're evaluating the function at that particular number. But since we don't have that restriction here, let's go over to the TI as our first type of technology to investigate. So the first thing you want to do is hit the y equals button and put in the function that we're using. Once you have the function in, we're going to look at the table. Now when I first look at my table, it already has values filled in, which is good this time, but not always good. Sometimes we have fractions that aren't going to look as pretty when I look at the table, so what we want to do instead is go to the table set and change the independent to ask. Only change the independent, everything else stays the same. I go back to the table, and now I get to put in the values. So I put in 1, negative 1, 2, negative 2. The only one that gives me a 0 is the 1, so I remember that when I go back over to my notes. If you want to use Desmos instead, you start the same way. Once you have the function in, then you could add a table by hitting Edit List, go to the table, and it populates values for you, or you can type on top of them. You can also just type f of 1, f of 2, just like we did in the TI, so you pick what you want to do. If I click on the graph, it does show me the zeros. I see one at 1, 0, I see one at 0.562, I see one at negative 3.562. The problem with this negative 3.562 and the 0.562 is these are not rational numbers, which means they've been rounded. We want to have exact values. Since these numbers have been rounded, we want to go and find out what they are exactly, which means we need to head back over to our notes and do some more work. So we found out f of 1 is 0, which immediately tells us x minus 1 is a factor of our function. So we're going to use that along with synthetic division to kind of make this a little bit smaller. So remember with synthetic, I put a 1 over in a box, and then I put the coefficients, 1, 2, negative 5, 2. I bring the first number down, which is a 1. 1 times 1 is 1. I add that together. 1 and 2 gives me 3. 1 times 3 is 3. When I add that to negative 5, I get a negative 2. 1 times negative 2 is negative 2, which gives me 0. The 0 is super important. It tells me that I did my division correctly and I have the right factor. What I essentially did is I divided by x minus 1. So this means I brought the power down. The 1, 3, negative 2 stands for x squared plus 3x minus 2. Now our next step is to find out when is this equal to 0. I'm always going to try to factor first. So I look at factors of negative 2 and I try to make them add up to 3, and we're not going to get anywhere. So what we're going to be forced to do is use the quadratic formula. So in this case, a is equal to 1, b is equal to 3, c is equal to negative 2. So I have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 2 all over 2 times 1. We can make that x is negative 3 plus or minus the square root, 3 squared is 9, negative 4 times 1 times negative 2 is a positive 8, this is over 2. So this is negative 3 plus or minus the square root of 17 over 2. Let's go back to Desmos real quick so I can show you something about that. I'm going to put this in parentheses so I don't lose anything. Negative 3. Let's just do plus the first time. I'm going to do the square root of 17 and then divide by 2. And do you notice I get a 0.56, which is what we had over here when we were looking at our intercepts earlier. So watch if I just switch this plus sign to a negative sign. Here's this negative 3.562. So even though we can see there's similar values, it's really important to have this exact answer that has a radical in it. So you're going to have to use quadratic formula sometimes or other methods like that. You can't just use the values you get from Desmos or the TI calculator. Before we move on, let's see, how would I answer this? So if I had this question that started back here with find all the zeros of x cubed plus 2x squared minus 5x plus 2, my answer would be x is equal to 1. And then it would be negative 3 plus the square root of 17 over 2 and negative 3 minus the square root of 17 over 2. So what I have here is a list of answers. I just separate them by a comma. Depending on the program you're using, some programs may want you to have the little set brackets around it, but it should tell you what you're supposed to do. So let's try another one. This one's a little bit bigger. I have 2x to the 4th plus x cubed minus 7x squared minus 3x plus 3. So again, I'm starting with p, which this time is 3, and it has factors of plus or minus 1, plus or minus 3. Q is 2. It has factors plus or minus 1, plus or minus 2. P over Q, I have plus or minus 1, plus or minus 3, and that's from dividing by 1. Then when I divide by 2, I have plus or minus 1/2 and plus or minus 3/2. So this time I have 2, 4, 6, 8 numbers to put in. I'm going to go directly to Desmos this time, but you could use the TI. It doesn't make any difference, but let's see if we can figure out if any of these are answered. So remember, we're checking f of 1. Negative 1 gave me 0, so there's one solution. We wanted to look at f of 3, f of negative 3, f of 1/2. Here's another 0, f of negative 1/2, f of 3/2, and the last one, f of negative 3/2. So going back through, 1/2 was 0 and negative 1 was 0. Just like before, we can click on here and we see here's where our 1/2, here's our negative 1, but then we have these two other solutions we needed to figure out. So of our possible rational solutions, the two we said that work were negative 1 and positive 1/2. So we're going to use synthetic division to find the other solutions. It doesn't matter which one you start with. I'm going to start with negative 1, and I'm going to write my 2, 1, negative 7, negative 3, and 3. We're going to bring down the 2, multiply by negative 1, which gives me negative 2. When I add, I get negative 1. Negative 1 times negative 1 is 1. Add that to negative 7, I get negative 6. Negative 1, negative 6 is positive 6. When I add that to negative 3, I get 3. Negative 1 times 3, negative 3, that's 0. That's what I wanted. Don't start over. Stay where you are and put the 1/2 in a box underneath. What just happened is we were at power 4. This is now a power 3. We're going to go through again, and that's going to drop it down to a power 2. 2 comes down. 1/2 times 2 is 1. That gives me 0. 1/2 times 0 is 0. That gives me negative 6. 1/2 times negative 6, negative 3. That gives me 0, and I stop. This now says I have x squared. This says 2x squared plus 0x minus 6, and we want to set that to equal to 0. I can drop this 0x, it doesn't help me, so I have 2x squared minus 6 is 0. Here I don't have to use the quadratic formula, I can use the square root method. This says that 2x squared equals 6, x squared equals 3, so x is plus or minus the square root of 3. So that gives us our other two solutions. So we're going to take everything we know. We know our 4 solutions. We had x equals negative 1, 1/2, the square root of 3, negative the square root of 3. And this time we're also going to write our function in factored form. So remember, the negative 1 says it's x plus 1. 1/2 means I have x minus 1/2. I have x minus the square root of 3. I have x plus the square root of 3. So completely factored form. There's one little problem right now. If I were to multiply this out, all these x's together would give me x to the fourth, but I'm missing this 2. Kind of what happened back in this last step. I divided by 2 right here. So what I want you to see is this is 2 times x squared minus 3, and I dropped this 2. So we want to put that 2 back in. It also takes care of this 1/2 that I have in here. So when I multiply by 2, I'm going to think about multiplying right here by the x minus 1/2 to get x plus 1, 2x minus 1, x minus the square root of 3, and x plus the square root of 3. So here I distributed to get rid of the fraction and to bring in the leading coefficient that I need. So that's an important step that's easy to miss. So really watch for it, kind of look for, do I think I have the right leading coefficient if I were to multiply this out? Don't multiply it out, that's too much work. Usually it has to do with a fraction somewhere in your function, and then you just kind of clear that fraction and it'll introduce the right coefficient. So let's try another one. This one's worded a little different. It says find all the roots of 4w cubed minus 30w squared plus 66w minus 40 given w equals 4 as a root. So I'm already giving you a solution. So let's go ahead to synthetic immediately. I have 4, negative 30, 66, negative 40. And why this is super helpful is I'm taking it from power 3 down to power 2 really quickly, and we're usually pretty good at anything that's power 2, so we can kind of skip that looking at Desmos or the TI this time, doing the rational roots, and just jump right into synthetic. So I brought the 4 down. 4 times 4 is positive 16. When I add to negative 30, I get negative 14. I do 4 times negative 14, and that gives me negative 56. 66 minus 56 is positive 10. 4 times 10 is 40. I add and I get 0. So really quickly, I drop down to this is a w squared. This says 4w squared minus 14w plus 10 is equal to 0. Now we have a bunch of ways to go about it, but I'm quickly going to try the AC method that says if I take 4 times 10, so the value of A times the value of C, I get 40. And I think, are there values of 40 that add up to 14? And there are, before and 10. So I can write this as 4w squared minus 4w minus 10w plus 10 equals 0. So do pay attention to the signs when you factor to make sure you have that same sign in the middle when you split it up. So 4w squared minus 4w, I'm going to take a 4w out, leaves me with w minus 1. Negative 10w plus 10, I'm going to take a negative 10 out, and again it gives me w minus 1. What you want to think about is if I divide 4w squared by 4w, I just get w. 4w divided by 4w, there's my 1. So you're just doing division. Some people tell me they think of it as undistributing. I'm okay with that. You're just factoring. What should happen is this little magic where w minus 1 is the same as w minus 1, so I take it out, and I get 4w minus 10 equals 0. This says when w minus 1 is 0, w is 1. When 4w minus 10 is 0, 4w is 10, w is 10 over 4, but make sure you reduce that to 5 over 2. So I have 5 over 2, I have 1, and I have the 4 we started with. So I'm going to write it at the very top because I ran out of room. My roots are 4, 1, 5 over 2. The order of writing the roots doesn't matter. Just make sure you write all of them in. This time I have find all real zeros of z to the fourth plus z cubed minus 23z squared plus 3z plus 90, given it has a 0 of multiplicity 2 at 3. So this is the big difference here, is that I have 3 2 times. So let me show you how that appears. We're going to start with synthetic. Here's my 3. I have a 1, a negative 23, a 3, and a 90. Bring the first one down. So there's the 1. 3 times 1 is 3. I add, I get 4. 3 times 4 is 12. I add, I get negative 11. 3 times negative 11, negative 33. That gives me negative 30. 3 times negative 30, negative 90, which gives me 0. I used 1, 3, so this was z equals 3. Let's do it again. So this is what the multiplicity means, is it's there twice. So bring down the 1. 3 times 1 is 3. When I add, I get 7. 3 times 7 is 21. When I add, I get 10. 3 times 10 is 30. When I add, I get 0. So this was z equals 3 a second time. We started at power 4. So when I divided the first time, now I'm at z cubed. When I divide the second time, I'm at z squared. So 1, 7, 10 means z squared plus 7z plus 10 equals 0. I have factors of 10, 2 and 5, that add up to 7. So z plus 5, z plus 2. This says z is negative 5, and then z equals negative 2. So my zeros are 3, negative 2, negative 5. You don't have to write the 3 twice, even though it happens twice. To write it in factored form, I would have z minus 3 squared, z plus 2, z plus 5. Remember, you're always flipping the sign. So it said positive 3, I write negative 3 in my factor. It said negative 5 and negative 2, so I write positive 2 and positive 5 in my factoring. So for good measure, let's try one more, and this one looks pretty big. I have 12x to the 4th minus 23x cubed minus 234x squared plus 225x plus 100. One of the biggest things that makes this one so much larger is this 100 and the 12. P is 100. So my factors are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, plus or minus 50, plus or minus 100. It's a lot. Q being 12, I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So from here, we're supposed to come up with our P over Q, which I think would take a really long time. So what we're going to do instead is kind of be smart. We're going to go over, I'll use Desmos because I think it's quicker, and I'll kind of step you through some thoughts I have to how we can get this a little bit better. First thing I always say is double check, make sure you entered it right. So I have 12x to the 4th minus 23x cubed minus 234x squared plus 225x plus 100. We could start plugging in some of the integers we had, like 1, negative 1, 2, negative 2. We can also kind of look at this graph to get a big hint here, because when I click on it, I can see it says 5 is a 0, negative 4 is a 0. This is 1.25, which I think we can get through, and then negative 0.33. So this time, just by looking at the graph, I can see all of the zeros, and I don't hate that method of how to do it. This other way takes a really long time. So let's just take that over, let's convert it back to the numbers how they should be, and then let's write our answer. So we had negative 4, negative 0.333, 5, and 1.25. The negative 4 is good, the 5 is good. We don't want to leave the negative 0.333, we want to say that's negative 1 over 3. In 1.25, that's 1 plus 1/4, which hopefully we know that's 5 over 4. So our solutions would be negative 4, negative 1/3, 5, and 5 over 4. Let's go ahead and write this in factored form so we get practice with that one more time. So negative 4 tells me I have x plus 4. Negative 1/3 says I have x plus 1/3. 5 says x minus 5. And then 5 over 4 says x minus 5 over 4. Now, if you remember back, our leading coefficient was 12. So we need to make sure this is also a 12. I have two things that have fractions. I have a 1/3 and I have a 5 over 4. So I'm going to say let's multiply a 3 through the x plus 1/3, and let's multiply a 4 through the x minus 5 over 4. I have x plus 4, 3x plus 1, x minus 5, and then 4x minus 5. So that way the 4x times 3x times x, that'll give me my 12x to the 4th. And then you can also check that 4 times 1 times -5 times -5 is a positive 100, which is our last term. So you do want to do those little checks, make sure that your factored form agrees with your original function. I'll do one more video that has some that have complex solutions, just so we have a little view of everything. So if you need to see a couple more examples, know that I have them coming. Good luck.